Yeah, good morning YouTubers. This is Spanner Man again with another video. Main reason I'm making another video, I had a few requests from people on some of the previous videos that I did, and they said that look, while it was good, while I was telling people how to do something, I wasn't really telling them why I was doing it. So I guess I'll go in a little bit more detail, probably more a bit about the geometry of the the tooth, the chainsaw tooth, and talk about a few things, and we'll see how we go. First of all, I guess I'll concentrate on the actual tooth of a chainsaw, and I've got a little tiny one made up here. This is just a copy of something that I made that represents the side of the tooth. Now, as you can see, there's an arrow there and it points to the gullet. Now, the gullet is exactly right here, right down the bottom. Why is that important? Well, that's important that you maintain when you're grinding or filing, that when you grind the tooth away, this C shape here, that it's not up and down. You want it like a flat line, so you're grinding evenly. As you grind away nice and even, and you want to maintain that shape. And normally the file, as the file sits in here, the file just protrudes on the top, so it's got that nice beautiful C shape. Now that's with a file, because a file doesn't change, but it's a little bit different when you've got a grinding wheel. So what I've actually made up is this piece of paper which represents a grinding wheel. Now normally we grind at 60 degrees, and this is a 3/8 chain that I'm going to be that I've got here on the grinder, and we use a 4.7mm wheel. So if we have a look at what I've made up, if you come in at your 60 degrees, this is the angle that you want to come in at. Now if you set it at a lower degrees, you'll find there's a gap up at the top here. If you set your grinder going more towards, getting towards 60, 65, 70 degrees, you'll find there'll be a gap down the bottom here. So 60 degrees is the standard for most chains. So that's what you want to do. So as you bring your grinding wheel in, you come in at this angle, and as you slowly grind away, you'll need to adjust the raker height. So this is the raker, and that's the little mark it's on there. Roughly, I don't know, it's probably about 3mm from the top to the bottom, which is probably roughly the same between the top and the last part of the chain is about 3mm. If you look at the slope, so the slope probably goes down about 3mm. So it's a proportional thing that as you wear the chain down, you take a little bit off, but you get a raker gauge, and and that's a different video. So when you look at a tooth, so when you look at the front of a chain, that's a full chisel tooth. That's roughly what it looks like at the front, and this part here is the raker, so that as you hit the timber, this sharp edge on here, this razor sharp edge, that's what you've got to try to achieve, is the most important thing. So the grinding wheel, this edge here needs to be razor sharp, and this is the other edge that protrudes out. So this is your main work area, your cutting edge. And down the bottom here, this is what we refer to as the gullet. So this is the top edge, this is the side plate. Another thing that's interesting, that they chrome plate the side plate and they chrome plate the top of the tooth. So you'll find out that the whole idea of the chrome plating is to make the tooth last longer. Now, most chains that you get these days, the standard chain has what we call a 30-degree top plate angle. So when we have a look at a chain in a minute, you'll see that that's your 30 degrees. So that's the angle. That's a fairly standard angle. If you're using a million chain, it could be 15 degrees. So different angle altogether. So we're just talking about semi-chisel and full chisel chains at the moment. They're the most popular. So just to show you the difference between a semi-chisel and a full chisel chain, that's a full chisel chain, very sharp at the corner, and this is a semi-chisel chain. Has that radius on the corner. Now the difference is, when you've got a full chisel chain, the tip of the chain is very pointy. So if I can just try and demonstrate this, see if this makes a little bit hard to do. I've got, if that's the point of a full chisel, that's the first part that's going to go into the timber. And if it hits a bit of dirt, it'll blunt very easy. So a full chisel chain is generally used on soft timbers, whereas a semi-chisel chain is your better all-rounder. I tend to like full chisel chains better than semi-chisel because they cut better. Even in harder wood, I still prefer a full chisel because I'll sharpen them up. So okay, now we'll go, that's a little bit of a brief explanation on some chains. The next we'll talk about the grinder. Now this grinder over here is a mid-range priced grinder. The wheel that I'm using on this is not your standard cheap Chinese wheel. It's still a pink aluminium oxide wheel. It's about double the price of a standard wheel, so it was about $27. It's made by Kinik, K-I-N-I-K. They're a Taiwanese company, and they sell worldwide, so they've got a pretty good reputation. And probably one of the main things is with these wheels that when you spin them, that the really cheap ones from China tend to have a bit of wobble, and that could be up to 1 millimeter, which is not very good. This one here, not perfect, but getting close. Now, one of the big differences between a file and a grinding wheel is your file is perfectly round. Your grinding wheel isn't perfectly round, the radius that's on the bottom. So what we've got here is a plastic card to measure the radius of your wheel. So what you actually do is put, so in this case here, this is a, we will use this 404/7/16. And what you're trying to achieve is make sure that your wheel has got that nice curvature. Now, if it hasn't, you get a dressing stone with this grinding wheel, or this grinding unit that I've got here. It came with the dressing stone. So you dress the stone up and then you put the card back in here so that you got the nice curvature. So you try and get it as close as possible. Now, the other thing that's interesting when we talk about grinding wheels and files, there's no such thing as a 5.2 or a 5.5 millimeter grinding wheel. No, it's 4.7 or 4.8. So the grinding wheels are actually smaller than the files. That can present a couple little small little glitches, and I didn't experiment here. You can see the dots, these 3 dots. And what those 3 dots are is the first one, I ground this head angle at 60 degrees. The second one, I ground this tooth at 55 degrees. This one I ground at 50 degrees. And what I did after that was lay a 5.2 file, which is this one here, right into the tooth and had a look at the gaps. Now, when I say the gaps, this grinding wheel here has a profile. It'll grind that profile at 60 degrees into the wheel. So we'll set that up in a minute and we'll show you. But what I wanted to find out, that if I ground a tooth at a certain angle and I took that out in the field and I had to use a file, would that file follow the profile? How accurate would it be? And what I found out, that a 5.2 millimeter file wasn't the best file to use after using the grinding wheel. If I took a brand new steel chain and laid a 5.2 millimeter file into the tooth, it fitted almost perfect. So if I was going to just use a file, I would use a 5.2 millimeter file. If I'm going to use the grinder and a file, I found out that the 5.5 millimeter file fitted better. Now, to actually tell you how that worked, what I actually found out was the 5.5 millimeter file fitted this area much better, whereas the 5.2 millimeter file fitted the middle part of the tooth better, but not up at the top. So there was a little tiny gap up at the top. Now, what does that all really mean? What that means is that if you're grinding chains on one of these wheels, and then you go out in the field and you're using a file, and you're using a 5.2 millimeter file, it will mean that you've got to grind more strokes than if you used a 5.5, because a 5.5 millimeter file actually fits better into the tooth. And you can probably see, yeah, on that tooth there, it's what we would refer to as the C shape. So what I'm actually talking about is that when we place a file in here, you can see how that fits very nice. That fits beautiful. But there is a slight little gap. And if we to put a 5.5 millimeter file in there, it actually fits better. Now, you really can't see much, but it's more on the top here. This top edge. This is the top plate. So the top plate edge is the most important. Now that's the top plate edge here. 30 degrees. So we'll talk about that at the moment. So if we set up this grinder, the actual angle at the back, so we've got two things here, so we'll just sort of go over a few of the adjustments. This adjustment here will set the depth that we come into. Now, how do you set that up? What's the correct way? Well, the correct way to set that up is you don't grind any more down into the bottom of the gullet. Now, the gullet, before we had this piece of metal, this is what we call a gullet, right down the very bottom. So therefore, this wheel has to come right down in the bottom of the tooth. So we'll angle the head to 60 degrees and we'll set this up. So first we'll angle it to 60 degrees. Now there's adjustment on the back here. There's a knob here. And at the very back there's graduations. You can see the graduation. So we start over here at 50 degrees and we go over to 90 degrees. There's also at the very front, it's a bit difficult to see, it's at the side there. There's also some graduation. So what we need to do is, I found out that 60 degrees works better on a 5.5 millimeter file. So we'll just adjust this and bring this over to 60 degrees. Now, that's set and forget. I'm not going to adjust that anymore. That's our 60 degrees. That's our top plate angle. That's the angle that it comes in. Now, what we want, the most important thing, that we have an extremely sharp edge there. That's the most important. That's the part that cuts, and the side plate, the side, which is the side plate here. So that side plate and the top plate are the most important, and they're chrome plated. So that actually gives them a bit longer to stay. You can actually see the graduations on the here as well. So you got both. Now, a lot of the cheap plastic grinders, you can't adjust the head. But as I said, I've experimented with 60 degrees and found that 60 degrees works best. Now, I don't know whether you can see the radius of that wheel. Yeah, you probably can just see, yeah, you might be able to see it. See whether, I'll just tilt the camera a little bit. Yeah, there it is. I think there you can see that. There's a nice little radius there, and that radius will be what grinds into the tooth. That'll be the shape. So the next thing to set up, you'll notice on the bottom here we have graduations. We start at 0 degrees. We've got 35 degrees to the right, 35 degrees to the left. That's your left tooth and your right tooth. So you've got an inner tooth and an outer tooth. Steel chains recommend 30 degrees, and Oregon recommend 25. Now, like the top plate angle, if you keep swapping and changing degrees, like, you know, you play around with 25 degrees or 35 degrees or 30 degrees, and you play around with the top plate, you'll find out that you'll be grinding. This is the same chain we're talking about. So if you go out in the field and you say, oh, look, I might try this, I might try that. If you keep on playing around with the settings, every time that you change a setting, you've got to actually grind off probably a good 0.5 millimeter, if not up to 1 millimeter, before that new profile really comes in. Because when you change, say from 25 degrees to 35 degrees, you'll get a gap at one end of the tooth. So then you've got to grind the excess metal away till that new profile comes in. So it doesn't take much. So if you stick to what the manufacturer states, you can't go wrong. So on your standard chain, general purpose chain, semi-chisel or full chisel, it'll be 60 degrees on the head and 30 degrees on the top plate. So we'll set that at 30 degrees. It's all locked in. The next thing that you have to do, we spoke about it before, is how far you bring this wheel down. Now, on a brand new chain, it's so easy to set up. On a second-hand chain, we spoke about the gullet. And in this case here, you'll bring the wheel down. And I've got to try and get in there a little bit better and zoom in there so that you can see exactly what's going on. Yeah, that doesn't look too bad. We'll try that. So if I bring this grinding wheel down, it just fits in there and it just touches the bottom, which is the gullet. So if I can get something to point to it, so the bottom here, this very bottom here, is called the gullet. This is the top plate edge. This is the 30 degrees that we're talking about. So when we look down on top of the tooth, when we look down on top of that, that's your 30 degrees. That edge is so critical. And the front of this, which protrudes out more than anything else, is the first part that will hit the timber. So if this edge is a little bit blunt, your chain won't cut. More so on a full chisel. And the next most important part is the side plate. So on this tooth here, you can see the side plate here. So where the top plate, let me just see if we can get a better shot of that. Where the top plate and the side plate intersect, that's where that radius is. This is the first part that hits the timber. So if you can't maintain a razor sharp edge here, you won't cut. And also the gullet, whether you use a file, must be clean at the bottom. So in other words, it must be at the bottom, where that line is there. You can just see that. Right at the bottom of that line there is where the gullet is. That's referred to as the gullet. So as you grind away the tooth, as we explained before, as you slowly grind the tooth away, where that line is, and the arrow it says gullet, you want to maintain that straight line. Okay, so we adjusted the top adjusting nut so that's our depth. That's our 30 degrees set in the position, and this wheel here and this lock nut here will push the tooth closer to the wheel. So we need to set that up. So if I just back that off for demonstration purposes, as we bring the wheel down, you'll see that gap. So what you need to do is slowly wind that up, and you'll see that the grinding wheel will drop in, and it's just got a touch. And you can tell by, you'll see that happening now. All right, so that's the point where it's where you want. So you lock everything back up. I'll just tighten that all back up. Bring it back down. It's just touching. Okay. So the grinding wheel will come right down to the bottom of the gullet, and it'll just touch the side of the tooth on the top plate, and it will grind the side plate, and you'll get a nice, beautiful sharp edge. And a lot of people make a mistake that when they bring the wheel down, they just bring it down and they just bring it in and hold it. And then you'll hear stories where people say, oh, you know, I really prefer to file because those grinders burn the tooth. Well, you can get an angle grinder, any type of grinder, and if you push it hard into any metal, it'll turn blue. And yeah, you'll lose the temper. So these things aren't designed, they're not an angle grinder. You're not supposed to bring this wheel down and go whack into the tooth. You bring it down nice and gentle, and you just touch the tooth, very gentle. Even if you lift it up a little bit, off, on, because as you lift it up, it starts to cool down. So if you just take your time, you'll find out that it will grind okay. So that was our starting point. We've got our depth set. We've got our tooth is set so that it's just touching the wheel. We've got our 30 degrees set. So what we'll do now is turn the grinder on and bring it down, and we'll just touch the tooth. See? That's how I like to grind a tooth. And if you touch the tooth, it's cold. It's not even hot or warm. It's beautiful. Now, if I could come around, I'll just turn the grinder off. See if we can get a shot of that tooth that was just ground. Zoom in a little bit there. Yeah, look, that just sort of shows you that's a nice, beautiful grind, and you can see the gullet. So there's the gullet right down there, right there. So what you want to try and maintain, that as you grind this tooth, try and keep it reasonably flat. Now, occasionally, sometimes you might get the file. If you're not happy with it, you might actually get the file and try and push like that. Now, when I did that, I just noticed when I held this file in there that this gap here, if you hold the file at the wrong angle, you can see the gap at the back. If you hold it that way, you'll get a gap at the front. And this is why it's so important that when using a hand file, that you push the file into the profile and maintain it as you push the file through. Lift the file back out and push it through. Maintain that constant line. What you've got to try to avoid if you're using a file, you don't go up in the air, because can you see the gap at the back? Of course you can. I'll just exaggerate that. So this is what you don't want to do. You don't want to be filing like that, because all you're going to do is you're going to take metal off the front of the tooth and not the back. And same, vice versa. You don't want to be grinding like this, taking metal off the back and none at the front. What the idea is that when you push that file into that groove, that you're filing everything, the top plate, the side plate, and all simultaneously. So you're taking metal off everywhere at the one time. And this is what the grinder achieves. The grinder will take off metal in every spot. And that is very sharp. That is a very sharp edge. And that's all you want to achieve, is a very, very sharp edge. So there's 18 teeth on the far side, and there's 18 teeth on this side. So once you've sharpened one side, then it's just a matter of coming down here and adjusting 30 degrees on the other side, and then sharpening all the other teeth. So look, I hope that video helps. Just remember that even if you've got a cheap grinder and you can't adjust the head angle, because I've got some cheap grinders here as well, and you can't adjust this head angle. It's set at 60 degrees. 60 degrees is the most common, which only leaves you this here, your 30 degrees. Now, the other thing that I haven't mentioned about this particular grinding unit is the original manufacturer of this. This is a copy of an Oregon, which is a beautiful, look at the Oregon grinders are beautiful. And Oregon recommend that you tilt, this is called the vise actually. Oregon recommend that on their chains that it has 10 degrees tilt forwards and backwards for the left side and the right side. And what that actually means is that you can pull that forwards or you can pull that backwards and lock it up. Whole idea of that is that it changes the angle. Let's see if we can zoom in there a bit, see if that helps. Is that you change that angle. You can, it's 10 degrees, that's all it is, it's 10 degrees. And the whole idea is probably that it gets rid of the cutting edge. Everything seems to work. Well, that's what Oregon recommends. Still don't recommend tilt. They recommend 0 degrees. Yeah. So look, I hope this video helps. The only other thing that I might mention quickly is that when you're using one of these, there's probably only one other adjustment that I forgot to mention, is this wheel here moves this little unit over and backwards. So what is a really good idea is that when you get down, you've almost ground the chain, you'll find out that if you don't adjust this, the grinding wheel will grind off either side. So what you do, that when your chain starts to get down a bit, or it's a good practice in this case, what I did was push this over that side when I'm grinding this tooth. When I grind the other tooth, then I pull it this way. Now I'll actually show you a tooth that's ground down. I'll just go grab it. It's just I'll take this one off and I'll show you a chain that's done all of its life, and I just keep it here for reference purposes, just to show people. Right, now this chain that I've got here is a full chisel chain, and you'll notice that there's not much, there's no life virtually left in it. It's done its job. It's down to the marks. So we'll actually show you what that looks like. We'll zoom in there. And you can see that there's not much left of that. Now you can see that plate hanging right out here. So if we were to bring that wheel down, it will grind that off. It needs to be pushed right over a little bit further on the other side. I'll just see how much we can do that. That's about it. There's not much left there. If I was to bring it over, which I will do, you'll see what the difference is. As you can see, that's way over, and if you look at the tooth, and the grinding wheel will come down, and the grinding wheel would grind that plate off. So that adjustment, when you're doing the tooth that's furthest away from you, you need to push that bar across or wind it across, and you won't have that problem. Now you'll see the gullet here. This is the gullet, so you can see this part here, it's probably a little bit high, probably could have been ground down a little bit. And you can see my rakers, I probably grind my rakers a little bit lower. The distance, the raker should sit 1.67 of a millimeter below the top of the tooth. Now this is a full chisel chain, and if you look at the full chisel chain, You can see that sharp point, very, very sharp point. That is needle sharp. When you touch that, that is needle sharp. There's another picture of the gullet on that one, so you can see how like it's been up and down a little bit, so that's not too bad. But just see if we can see any others. Looking at which part of the gullet, you can't see that very good. See which, I think on that one, yeah, you can see that one there. That's, yeah, just interesting when you look at that one there. Right, so that's not too bad. It could be better. They're all roughly about the same. But you can see the little mistake I made on this one here. I really, that needed to be cleaned up a little bit. So that's probably a little mistake that I've been making. But you know, no one's perfect. So, but that's virtually the end of the chain. So only one other thing that probably is some good advice to tell you about a chain is how to keep the chain for a long, long time without stretching. Still maintains, they say that their chains are pre-stretched. So, but you always get some stretching. And I had a friend that gave me a couple of steel chains because he sold his chainsaw and he was getting a bit older, so he wanted a smaller chainsaw. So he sold his Farm Boss, which was 20-inch, and he went to an 18-inch. So he had a few chains left around. They're in pretty good nick, except for one. Anyway, he'd hit a rock with it, and the chain was, you know, like 2-3 millimeters. There was about a dozen links that were really damaged badly, and I thought, oh, I'll grind it up. And it took me actually quite a while. The chain had only been used a few times, but I reckon I had to grind away about 3 millimeters because the rocks just damaged the chain that much. Took the corner right off. Anyway, I ground it all up and thought I'll go use this, and I put it on my chainsaw, and then I found out, wow, the adjustment for the length of the chain wasn't much left there. The chain had stretched incredible. And the only way that it can stretch is that because he hit rocks, and I guess you could call it, if you abuse the saw, in other words, you know, you hit dirt, you hit rocks, the chain is going to stretch a lot. Or if you're using your chain and it's blunt and you push down hard on it, it's wearing your bar out, it's wearing the bottom of the links. Everything is under a lot of stress, and it will wear at a much faster rate, and it will stretch. So if you can keep your chains razor sharp as much as possible, you will find out that your chain won't stretch that much over its life. This chain here hasn't stretched that much at all, and that's only because I kept it sharp as a razor. And the moment that I feel that it's not cutting properly, two things: I stop, I refill, and I get the file out, and I'll give it a file. So yeah, and that's what I do. So this particular chain, I've used this in the field probably the last 2 years. I've got about 6 or 7 chains that I take out with me, and I probably cut about 18-20 cubic meters of timber each year. So with 6 or 7 chains, I'll probably go through a chain a year. That's all I'm using. So yeah, I'm not a professional. I'm just a backyard person that uses a bit of timber for firewood. So, you know, I don't drop trees, although I have dropped a few trees in my life, fairly big trees that are about 2 foot in diameter. So I've only done a few of those. But generally I use a chainsaw for firewood and firewood only. So yeah. So look, I hope this video has really been helpful, and if you I'll just recap very quickly before I finish. 4.7 millimeter wheel for a 3/8 chain or a 0.404 chain. If you're using a smaller chain like the 3/8 LP, you've got a 3.2 millimeter wheel. They don't make a 4.8, or sorry, they don't make a 5.2 millimeter wheel or a 5.5. They do make 3.2, 4.7 and 6 millimeter. They're the only three wheels that you can get. The wheels are always slightly smaller than the files. I don't know why that is, but that's the way it is. Using this particular wheel, it's set up at 60 degrees. If I grind the chains, I find out that if I need to file them, I need to file them with a 5.5 millimeter file rather than a 5.2 millimeter file, because the 5.5 millimeter file seems to fit into the gap. And if you look at surface contact, so if you were to put the 5.2 millimeter in, I'll just sort of hold this up again. If you to put the 5.2 millimeter file in here, you'll find out that it touches this area but misses the top area, and the top area is the most important. So what that will mean is that you've got to grind this metal away before you start grinding the top. Whereas if you use a 5.5 millimeter file, which is slightly bigger, that it fits in better and has much more better coverage of this shape here. And I've tried that not once or twice. I've tried that actually quite a few times and found out that it fits a lot better. So that's up to you. You might find out on your machine that if you use, I have seen these wheels advertised 4.8 mil, and I've also seen them advertised at 4.7. So whatever machine that you've got, after you do a grind, if you've got, and that's assuming that it's a 3/8 chain like this, if you've got a 5.2 file, lay it in there and see how much surface contact area that the file sits on. And if you've got a 5.5 millimeter chain, do the same thing. Lay it in there and find out how much of the area surface contact that it touches, and go for the file that fits best. Now, 3/8 chain, you'll find out that still recommend a 5.2 file. That is the file that they recommend. And a brand new chain, if you've got a brand new chain, the 5.2 millimeter fits the chain better. So if you were a hand filer, then you would use the 5.2. You can use a 5.5. It's only 0.3 of a mil difference. Doesn't sound much, but it's not going to make a big difference. So it's just some advice to think of, that what file do you use? You can use either a 5.2 or a 5.5. It's just that I found out that after using the grinder, that a 5.5 millimeter file actually fitted in the profile much better than a 5.2. So that was what I found. You can do the same thing. If you find on your machine that a 5.2 file fits better, use the 5.2, because 5.2 is recommended anyway. But there is a difference between a file and a grinding wheel, because a grinding wheel tries to emulate what a file does, or vice versa. So they're both trying to do the same thing. They're trying to put a C shape on an angle, a C shape on a 60-degree angle, like this. So that's if that's your 60-degree angle, you're trying to put that C shape into the chain. And a file is much more accurate as far as its radius compared to a grinding wheel, although it's not super critical, long as it's close enough. Now, the other thing that I'll just briefly mention, and I will go, is that profile, after it's been dressed, if you're very gentle when you're grinding, you might find out that you only have to dress that once a year, maybe twice a year. It depends how much you're grinding. I mean, if you're a professional, you'd probably be dressing it every couple of days. But if you're only using your chainsaw about 10 times a year, like I'd do probably 10 days a year of chainsawing, about 4 hours each time. So I'll dress that up when it needs it, when I look at it and think, oh, that needs to be dressed up. So a wheel like this probably lasts me 5-6 years if I look after it. I have seen them with chips out of them, and that usually comes because people didn't take the time and effort to set this up, or they set it up while the wheel's running and then they bring it down, it goes bang. So yeah, take your time. The best advice that I can give to anybody about using one of these units is that you take your time to set them up. Set them up, and then when you've set them up so that it's only going to take a little bit of metal off. In most cases, it's only going to take about 0.1 of a mil, because if you go out in the field and you're using your chainsaw and you've just sort of blunted it a little bit, so you just thought, oh, it's getting a little bit dull, it's not cutting as good, so you stop and change or you file it. And you do that all the time, and when you get home, you can still use that chain. It's still sharp, but it's not razor sharp. So therefore, it only needs the edge cleaned up. And in most cases, you'd be lucky if you only take 0.1 of a millimeter off that chain. So it's only if you really blunten the chain and you dull the edges quite a bit that you'll have to take a lot more off. So it's not a good idea to really dull them, because if you really push it hard, you'll make it harder for the chainsaw, and all the moving parts will wear out much quicker. So it's much better if that chainsaw chain is razor sharp. It'll be easier on the chainsaw, and it'll actually be easier on you. You'll find out that your chainsawing will be a lot easier with a razor sharp chain, and it's not hard to do. Anyway, look, that's got 42 minutes on here, so I really hope the video helps some people, because for 12 years when I had a chainsaw, I made a lot of mistakes. Didn't realise that I did. And it's only been in the last couple of years that I've got about 6 chainsaws now, that I take my chainsawing much more serious than I ever did, and I realise that I can get super sharp chains and just as good. I guess the thing is that when you've got a brand new chain, and people will tell you this, they'll say, oh, it's a brand new chain, it cuts fantastic. Well, when you sharpen it, really what you're trying to do is restore that chain. That's what you're trying to do. You're trying to restore that chain back to its original sharpening, what's the best word to use? You're trying to restore it back to its original sharpening condition. And that's not too hard to achieve, whether you're using a file or a grinder. Personally, I don't like a file because it's labor intensive. Call me lazy, whatever. The only other thing that I will say about using a grinder is that a grinder will grind every tooth the same, left and right, provided you set it up properly. A file is very, very difficult to maintain that every tooth is exactly the same length. And 2 ways to check the length is either using a vernier caliper, or you can use a small little shifting spanner. And the whole idea is that you open the shifting spanner up and you measure the tooth. So you measure the tooth like that, and you do that on every tooth. So you can use a shifting spanner as a gauge, because remember that when you sharpen a chain, it's not for the life of the chain, it's only for 40-50 minutes while you're cutting, and then you've got to resharpen it again. So look, you can make a few mistakes, doesn't really matter. All as it means that the difference is that when I go out, and the guy next to me, if he doesn't sharpen his chains properly, he's there after 10 minutes playing with the file or swapping chains, and I'm there 40-50 minutes cutting twice as much timber as him because he hasn't sharpened his chains properly. Maybe he doesn't know how. Anyway, that's enough for now. So look, it's been 45 minutes. That's quite a long tutorial on sharpening chains, and I hope for the people there that wanted a better explanation that I gave a better explanation this time. So thanks for watching anyway, YouTubers, and till the next video, happy chainsawing. Bye for now.